All right, here we go. So we're going to extend what we know about logarithms to something called properties of logarithms. So here we go. We have something called the product property, and it looks like this. If I have the log of a product, we can extend that or expand that to be the log. If I have the log of m times n, that equals the log of m plus the log of n. The quotient property says if I take the log of m over n, I can change this to log m minus log n. And I want you to put a note over here for these first two. There's nothing in front of the logs. This is for the first two, okay? This is a critical piece of information. Product property, quotient property. There is nothing allowed in front when you split them or when you go from the split back. That's going to be important. The third property is called the power property, and it looks like this. If I take the log of m to the n power, you can do, the power property says you bring the power down, just the power, and it becomes n times log m. So we're going to do some practice, then we're going to do some extra marker board practice and just get a little bit comfortable. Right now it should feel a little uncomfortable, a little confusing, like what are you talking about? Rewriting expressions. You can use properties of logarithms to expand and condense logarithmic expressions. We're going to use this in 7.5 when we solve logarithmic equations. But in calculus, in particular, when we do something, like do you know how we add, subtract, multiply, divide? You square root. Okay, there's something in calculus called finding a derivative. And a derivative is a rate of change. I'm just planting some calculus seeds here, if you eventually get there. So when you do the derivative, we want to expand the logarithm because finding the derivative of individual logs is easier. Then, we keep talking about inverses. We have, so the inverse of a derivative is an antiderivative, okay? And so then when we do the antiderivative, it's easier to have the logs condensed. So please keep in mind that some of what we do, yes, we're going to use it a little later this year, but sometimes there's more meaning and application in the next course. So let's look at example 1. It says, I want to expand the log of 5x cubed over y with base 6. So watch this. I have a quotient. A quotient is a fraction or division. So my first step is I'm going to take care of the fraction. And I'm going to use the quotient property that says I can split the fraction into the log of the top minus the log of the bottom. Now, I want to go back up and explain my note, okay? When I have the power property, that only works if it's a power to everything. This has to be the log of everything to the n power. The 5 does not have a 3 on it. It does not have a power of 3. If I meant for that, there's going to be a parenthesis around the 5x cubed. So I cannot bring that 3 down yet. So watch what I'm going to do. I'm going to do the log of 5, base 6, plus the log of x cubed, base 6, minus the log of y, base 6. So right now, what I need you to be doing is just writing it down and thinking. It's okay if you're confused. That means you're learning something new. By the time I'm done with the marker board practice, That's when I'm going to check in with you to say, okay, now how do we feel about it? Right now, it's okay if you're like, I don't know what you're doing. That's all right, okay? So now, do you see that only the x cubed has a power that I can bring down? So my final expansion is log 5 base 6 plus 3 log x base 6 minus log y base 6. All right, we're going to do another one, then I'm going to let you try to. And again, it's absolutely fine if you're confused right now. You're learning something new. So here we go. If I want to expand the log 3x squared over 5y cubed with base 7, I have a fraction that's called a quotient, and I'm going to split it using the quotient property. So this is the log 3x squared base 7 minus log 5y cubed base 7. Again, I cannot bring the power down because the 2 is not on the 3. So this is going to be the log of 3 base 7 plus log x squared base 7 minus. Now I want you to notice something here. And this is a beautiful connection to pre-algebra and algebra 1. Do you understand that I have a minus in front of that log? I have to subtract anything that comes out of this log. I'm going to now split this log into a sum, but I have to subtract the sum. So watch this. This is going to go log 5 base 7 plus log y cubed base 7, but I have it in a big bracket or grouping symbol, parentheses, whatever you want. So now watch this. I'm going to do a couple of things here. All right, here we go. This is going to give me log 3 base 7 plus. Now I have log x squared, so I'm going to bring the 2 down. And then I'm going to multitask. I'm going to distribute my minus. Sorry, just that. I'm going to now distribute. I don't know what I just pressed. Yay. Okay, there we go. I'm going to distribute the minus sign and bring that power down. Okay, I'm going to multitask. I'm going to do two things there. All right, so take your time. All right, I'm going to pause, and I want you to try the got it number 1. Do A and B where we're expanding. Do as much as you can, and if you can't do anything, that's okay. Wait for me. I'll work it out and explain it. And you're going to have to look at those log properties till you get the hang of it. All right, here we go. I'm going to try letter A. This is going to be the log of 4x squared base 2 minus the log of 6 base 2. Then that's the log of 4 base 2 plus the log of x squared base 2 minus log 6 base 2. I'm not done, but can you understand what I've done so far? Good, good. Okay, most of you. So look, I've got a quotient. The quotient becomes subtraction. I have a product, which becomes addition. Now I'm going to blow your minds. I'm going to tie together what we just spent the last couple days on. What's the log of 4 base 2? Do I know that one? 2 to what power is 4? Oh. Okay, so sometimes they're going to work out to be something we know. Plus, I'm going to bring down the power. Do I know log 6 base 2? Is there a 2 to a power that gives you 6? It's not 3 because 2 cubed is 8. So then that one stays. So I want you to just stop and think. Okay, stop and think. That might be a teeny tiny little correction there. All right, now ln. ln is just the shortcut for a log with base e. Okay, so if you were not here, that's new. Log base e, we use the abbreviation ln. It stands for natural log. So I have ln 3 plus 2 ln x. All right, okay, so we should be moving a little bit more comfortable, but not all the way. And some of you might be there. That's great. Yeah.
Could you keep that into log? Is that still right?
Yeah, I'm not going to mark it wrong if you like to change it to log base e. Just be comfortable when you see ln to know that's log base e. All right, now we're going to go in the reverse direction. Expand means make it as big as you can. Condense means let's make it as small as we can. So now, let me go back up to the tippy top where I wrote that note. I think that's what I was thinking about. When you're condensing, this only works if there's nothing in front, okay? So let's look at example 2, letter A. If I have log 9 plus 3 log 2 minus log 3, I cannot do anything with that addition because there's a 3 in front of the log. So the only thing I can do is I can do the power property. Okay, when there's a number in front and you're condensing, the only way to condense power and quotient properties is you have to get rid of the number in front first. Now, we're going to yeah.
Unless it's supposed to look like that.
What 3?
I got it.
Okay, no, I brought that 3 up, if that's the one you're talking about. I brought that one up. I did the power rule. Now, I'm going to take the first 2, and I'm going to multitask here, okay? What is 2 cubed? 8. Okay, 2 times 2 times 2, that's 8. Then, when I combine log 9 plus log 8, okay, when I want to combine log 9 plus log 8, I multiply the insides. So this is going to be log 72 minus log 3. Okay, I did 2 things here, so let me talk you through it again. 2 cubed is 8. Log 9 plus log 8 becomes the log of 9 times 8. Well, I know 9 times 8. Then I'm going to do the quotient rule and make this log 72 minus log 3 becomes log 72 over 3. If you have a calculator, you can divide that, and that's log 24. I can't simplify that because it's base 10. That's going to be 10, 100, 1,000, and so on. So I'm just going to leave it like that. All right, let's try the next one. This is going to be ln 8 plus. I'm going to bring the power up because I can't do the product and quotient property with numbers in front. There's no number in front in those properties. So that's ln 8 times 25. What's 8 times 25? Isn't that 200? And then that's ln 200 over 10. You don't have to do a parenthesis, but if you sometimes like that, you can. I get ln 20. All right, try the got it number 2, condense. Condense means make it smaller. No, this is called a foldable. I'll have to.
Is this in the
No. No, this is, it's just a foldable. It's just going to kind of go over it one more time when we're ready here in a moment. Yay. Okay, good. You had it. That's awesome. Yeah. Okay, got it. Letter A. When there's a number out front, you're going to bring the power up. That becomes the power property. So I have log 5 base 2 plus log x cubed base 2 minus log y to the 6th base 2. So I take the first two, and that becomes the log of a product. So that's log 5x cubed base 2 minus log y to the 6th. Then I've got a quotient. So that's 5x cubed over y to the 6th. Don't lose your base. Once in a while I'll catch myself, I lose the base there. All right, then letter B. 6 natural log x minus 2 natural log y. You bring the powers up. So that's the natural log of x to the 6th over y squared. All right, if you flip this over, we have something called the change of base formula, but for our intents and purposes, if you have a graphing calculator, you don't need to worry about change of base. Let me show you on the graphing calculator. If you don't have a graphing calculator, you have to do change of base, otherwise you're stuck. So let me show graphing calculator people what to do, and then I'll show the people without a graphing calculator what to do. In example 3 on the back, log 8 base 3. If you have a graphing calculator on the left column, you see a 10 to the x button, right? Press second and that, and it lets you just type it in, the 3 and the 8. You see where it goes? And press enter. I got 1.89. If you don't have a graphing calculator, here you have to do change of base. And the change of base says you can rewrite this as log 8 divided by, and the log 3, this is the base, okay? The base goes in the bottom. And you'll just do the LOG button. Okay, so if you don't have a graphing calculator, we still get the same thing. Did you press the log button? No. Okay, you have to press Control 10 to the X. There. Put your little 3 there, and the big thing up there. And it just does it for you. Sure. Did I give you a little slip? All right, if you'll bring that to me.